Hello to you all. This is a lecture series on assignment number 4, that is the solution of assignment number 4. I will make one video for each problems. Currently I am discussing the problem number 10.8. Here the question asked was to plot I versus V for the given circuit. Means when the input voltage is increased from 0 to infinity, this voltage increased from 0 to infinity, what is the value of current. Likewise, when this voltage is increased from minus infinity to 0, what is the current flowing. This current we have to plot it. Okay, now in the problem itself it is given that the forward bias voltage drop of the diode is 0.6 volt. Means when this diode is turned on, a forward voltage drop will be there across this one. Likewise, when this is forward bias, 0.6 voltage drop will be there. Okay, now let's divide the interval of the V in this range. That is the first range I am considering 0 to 0.6 and then 0.6 onwards. Similarly for the negative side. Now when the input voltage V is in this range, this is also reverse bias, this is also reverse bias, then there will be no current. Means I is equal to 0. Now when the input voltage is more than 0.6 volt, in this range the current, this is going to be forward bias and this is going to be reverse bias, so overall positive current will be there. So the plot in the forward bias look like this one. Okay, up to 0.6 there will be no current, and after that there will be current. Some students are making the mistakes of drawing in this one like this one. Okay, this is a constant voltage drop model. Here it is mentioned that diode has only forward voltage drop. Basically they are considering the model of diode like this one. This is called voltage resistance model of the diode. Basically in modeling the diode, we have one ideal diode, one voltage drop, and then one resistance. Then only you are going to get this kind of, but in the question this resistance is not given, so we have to consider this model. So the current is going to flow, very high current is going to flow when the input voltage is more than 0.6 voltage. Okay, so the correct waveform will be like this one. Some students are also making the mistakes of drawing like this one, that is exponential. No, the in the question it is not mentioned that it is in real practical diode. Okay, nothing is mentioned, so this is also wrong. Okay, so only this is correct. Okay, now similarly when the input voltage is negative and between minus 0.6 and 0, the current there will be no current. This is reverse bias, this is forward bias. Okay, similarly it will behave. So there will be no current, and after 0.6 the current will be very high. So overall this is the curve we are going to get. Overall this is the correct curve. Okay, I have done all this explanation here. Okay, initially when the voltage is between 0 to 0.6, both diode will be reverse bias and there will be no current. Okay, when the voltage, input voltage is in this range, the current is going to be very high. So this is the curve. Okay, now it is represented by this model. Okay, this is 0.6. Likewise in the reverse direction, when the input voltage is between minus 0.6 to 0, there will be no current because both are not on. Okay, both are not on, so it will the circuit is like this one and the current will be 0. Okay, now again in this range it will behave that this has some constant voltage drop, this diode, and this is open circuit. Now as this voltage exceed 0.6, the current is going to be very high because there is no resistance in the circuit. Look, if there is some resistance, then you can include like this one. Okay, but there is no resistance in the circuit, so current is going to be very high. So overall this is the waveform. Okay, so those who have made the mistakes, they can correct themselves. Okay, thank you. We will meet in the next part of the same problem.